class instances.
Hi, my name is Koen. I'm a PhD student at KU Leuven under the supervision of Tom Schrijvers. And my work is called Bidirectional Type Class Instances, and it's a proposal for an extension to the Haskell type system, which addresses an issue with the interaction between JDTs on one hand and type classes on the other hand. So more specifically, for some JDTs, it can be surprisingly difficult to make them an instance of even really simple type classes. For example, this term data type, JDT, suppose we want to make that an instance of the show type class. Then we might come up with a simple instance declaration like this one. I think we can all agree that this seems quite reasonable, like it should compile, right? But in fact, it doesn't in current Haskell. And to see why, let's take a look at the second class of this instance declaration, where on the left-hand side, we generate locally a given constraint of the shape show pair of A and B, whereas on the right-hand side, we generate two wanted constraints, show A and show B. But this right-hand side does not follow from the left-hand side in current Haskell implementations, or current Haskell in general. And our key idea on how to address this issue is to have the type system treat instance declarations as if and only if statements instead of sort of a material implication. And this makes sense as long as we assume that overlapping instances are disallowed. And this allows us to actually derive show A, show B from show pair of AB. Of course, the answer we give here raises more questions, so I will briefly expand on some of the core challenges we faced and how we address them. One of the core challenges is how do we compile type classes then? So as you may or may not know, type classes are typically translated into an intermediate language like systemfc by using an explicit dictionary passing scheme. And we want our extension to be as minimalist as possible. And so we also want our extension to be a small extension to this existing established dictionary passing scheme. And long story short, that means that we want to store the instance context dictionaries in these type class dictionaries. But then we kind of immediately hit a roadblock because the number and type of instance context constraints varies on a per instance declaration basis. And this means that it's not immediately clear what we want, what type we should assign this field. Fortunately, the current intermediate language of GHC is systemfc, which allows us to express open non-parametric type level functions. And with some additional machinery, which I can't describe here, we can actually type this additional context field. Another challenge we face is how do we guarantee that our inference, our type class instance resolution algorithm actually terminates on all inputs. So the established algorithm for this is to use your instance axioms, which you get for each instance declaration, to simplify your wanted constraints, and then check whether, if they match the if they become a subset of the given constraints. But if we use, so we generate new inverse, like right to left instance axioms. And if we treat them the same as we do the regular instance axioms, then we might get into non-termination issues. We might start bouncing eternally between two wanted constraints, for example. So we keep treating them separately, and use them not to simplify the wanted constraints, but instead to extend the given constraints. And then in the end, we check whether the simplified wanted constraints match the extended given constraints. And this is guaranteed to terminate this new process, because the left-hand side of an instance declaration always has to be smaller in some sense than the right-hand side. So to make concrete what exactly we've produced, so I have provided a type system and elaboration specification and a type inference and elaboration algorithm, which are quite small extensions of the existing specifications and algorithms, which is nice. And then colleagues of mine have worked on the meta theory and a prototype implementation in the prototype compiler at KU Leuven. And that's it. So if there are any questions, I'll be happy to take them.
Thanks, Koen. So one question is, because your extension is incompatible with overlapping instances, how easy is it to detect if it's unsafe to use your extension? Do you also have to check the imports?
I don't really know. For our work, we assumed that overlapping instances don't exist. I'm not sure how this works with importing from modules that have overlapping instances. So I have not thought about that and cannot give a ready answer to that.
Another question that comes to mind is how often GADTs and overlapping instances are used in practice, to kind of get a sense of how often your extension would provide the right solution.
So how often GADTs and overlapping instances
are currently used?
Both of them at the same time then. Oh, there I really have no idea. I'm sorry, can't answer this question.
I'm also curious about what kinds of workarounds people currently use when running into the issues like the ones that you showed at the beginning.
Yeah, one of the things you can do, I go back a little bit. If you have your data type declaration, you could, for example, bake in the constraint in each of the constructors. But of course, that's very ad hoc, right? So you kind of need a separate data type declaration for each set of type class constraints you want to impose on it. So that's very bad for code reuse. Yeah. I don't really know of any workarounds that work in general, like just a lot of boilerplate, but they work. I have not found a workaround like that.
So your extension was motivated by this poor interaction between GADTs and type classes, and your solution is to make them bidirectional. But so are you proposing that all instances ought to be treated as bidirectional or just selectively?
That's an interesting question. In our work as we present it now, we do suppose that everything is bidirectional. But I think especially one of the reasons we did that is because we expect it to interact well with basically everything except overlapping instances. But overlapping instances can still be useful in some cases. So an avenue for future work is to see whether we can have a selective enforcement of tagging specific instance declarations, as this is allowed to overlap. This is bidirectional and therefore must definitely not overlap.
One last question. Is your implementation available for GHC?
No, there is no current GHC implementation, and the work is not yet underway for that. We first want to try to publish this as a paper, maybe get some feedback on it, gauge interest.
Okay, great. Let's thank Koen again.